Hi dear students, welcome to Gravity Tuition Center, Tirupati. Today, I am going to do problems from Introduction to Trigonometry of class 10. See, in exercise 8.1, the first problem is in triangle ABC, right angled at B. What does it mean? There is a triangle which is a right angled triangle, right angled at B. So, right angled at B means opposite to this side is called hypotenuse. This is what is called hypotenuse. Okay. Right angled at B, AB equal to how much? 24 centimeter. What is given? AB 24 centimeters. And BC 7 centimeters is given. Okay. Now he is asking to determine sin A and cos A. So, let us complete this triangle. See here we are given two sides and the third side hypotenuse we have to find. So, from the Pythagoras theorem, what does it state? The length of the hypotenuse square. Length of the hypotenuse square is equals to the sum of the lengths of the other two sides like AB square plus BC square. Okay. Now, AB is how much? 24 square plus BC 7 square. 24 24s are 576 plus 7 7s are 49. So, both of them add together it becomes 625. So, AC square is this much. If you take square root on both sides, what will happen? AC square root 625. So this cancels. AC is equals to root of 625, we know it is 25. It is 25. So what is the length of the hypotenuse? AC is how much? 25 centimeters. This is what we have found. Okay. So this 7, 24, 25 is a trigonometric triplet. So now let us find these trigonometric ratios sin A and cos A. So first sin A. What is the definition of sin A? Sin A means opposite side by hypotenuse. Opposite side by hypotenuse. So here sine of angle A. Where is angle A? Here. This is the sine of angle A. Opposite to this angle, we call this as opposite side. This is what is called opposite side, and adjacent to this angle is called adjacent side. Adjacent side. Okay. Now opposite side. What is the opposite side? 7 by hypotenuse 25. So sin A is how much? 7 by 25. Okay. What is the next thing? Cos A. So cos A is adjacent side by hypotenuse. Adjacent side by hypotenuse. So what is the adjacent side? 24 by hypotenuse is 25. This is how we find the trigonometric ratios when the lengths are given. So let us see the second part of this question. See here, the same question we have to find sin C and cos C. So AB is 24, this is 7, and this is already we have proved in the previous thing, it is 25. Okay. Now, what is the angle? Sine of angle C. So, we have to take this as the angle C. So, we know this is right angle. Right angle, the opposite side is hypotenuse. And this is angle C. Opposite to this angle is opposite side. And adjacent to this angle is adjacent side. Adjacent side. Now let us find the trigonometric ratios sin C and cos C. Sin C, definition of sin C is opposite side by hypotenuse. So what is opposite side here? It is 24. It is 24 and hypotenuse is 25, right? This is opposite side and this is hypotenuse. Next, cos C. What is the definition of cos C? Cos C is adjacent side by hypotenuse. So what is that? It is adjacent side is how much? 7 upon hypotenuse is 25. So this is how we found the trigonometric ratios of the sine of angle of C. Okay. Next, let us see the figure. In the given figure, find tan P minus cot R. In this is given and we have to find tan P minus cot R. So first of all, let us finish this triangle. See here we are given with two sides. Let us find the third side. Okay. Now see here, this is the hypotenuse. This is the hypotenuse. PR square is equals to PQ square plus QR square. Right? This is the from Pythagoras theorem. This is the thing. Now what we have to find QR. So let us send this to this side. PR square minus PQ square is equals to QR square. So PR, how much PR? 13 square minus PQ 12 square equal to QR square. Understand? So this is 13 is 169 minus 12 is 144. That is equals to QR square. So that implies QR square is equals to 169 minus 144 is 25. Understand? Now taking square root on both sides, QR square is equals to root 25. So QR root 25 is how much? 5 centimeters. So this is how much now? 5 centimeters. Okay. Now what is asked is tan P minus cot R. Tan P minus cot R. So let us redraw this drawing here. See here, this is right angled PQR. Now this is 12, this is 5, this is 13. So this is right angle, opposite to this is hypotenuse. Okay, hypotenuse, and first one is tan P, right? So let us take this angle. So opposite to this, opposite side, and next to this it is adjacent side. Adjacent side. Okay. Now tan, definition of tan. What is the definition of tan? Definition of tan is opposite side by what? Adjacent side. Adjacent side. Okay, what is opposite side? Here 5. And what is the adjacent side? 12. Okay, let us suppose this 1. Now again redraw this drawing. See here, this is P, Q, or right angled at Q. So this is hypotenuse. And what is asked next? Cot of angle R. So angle R here. Okay. So angle R opposite to this is opposite side. And next to this we are left with adjacent side. So already we have calculated, this is 12, 13 given, and we have calculated this as 5. So cot r. What is cot r definition? Cot is adjacent side upon what? Opposite side. Adjacent side upon opposite side. What is the adjacent side here? The adjacent side is 5, right? And opposite side is 12. So from 1 and 2, tan p minus cot r. Okay, from 1 and 2, tan p minus cot r is equals to tan p how much? 5 by 12 minus cot r how much? 5 by 12. So this is cancels and becomes 0. So the value of tan p minus cot r how much? 0. Let us move to the next problem. So if sin A is equals to 3 by 4, calculate cos A and tan A. In the previous problem, they have given lengths, but here he has given the ratio, trigonometric ratio has been given. So sin A is given, calculate the other cos and tan. So let us see here, let us draw a right angle triangle. Okay, right angled here. Okay, now let us take A, B, C. Okay, now this is right angle, right? Opposite to this is hypotenuse, and opposite to this is opposite side. See, opposite to right angle is hypotenuse, opposite to the angle, that's what we are going to define the trigonometric ratio, right? This is opposite side, and opposite hypotenuse, the leftover is here adjacent. So what is given? Sin A is 3 by 4. We know sin A means what? Opposite. Sin A is equals to opposite by hypotenuse. It is equals to 3 by 4 is given. Understand, this is ratio. So what is here? Sin opposite by hypotenuse. Opposite is 3, but hypotenuse is how much? 4. But this is not the length, it is not 3 centimeter, 4 centimeter, but it is ratio 3 upon 4. So what we do is we take it as 3k and 4k. This is the ratio. Understand? Now let us find the other trigonometric. See here, we have got two sides. Let us find the third side. So what is the Pythagoras theorem states? The hypotenuse square is equals to the sum of the lengths of the other two sides. Okay, BC square plus AB square. So what is the hypotenuse? 4k square is equals to BC how much? 3k square plus AB how much? We have to find. So if it goes this side, 4k is how much? 16. 4 4s are 16k square minus 3k square. It will 3k whole square. If it comes this side, 9k square equal to AB square. So 16 minus 9, 7k square equal to AB square. If you take square root on both sides, what will happen? This is root 7k is equals to AB. So AB is how much? Root 7. Understand? We have to take, this is 3, 4 and root 7. Understand? Now calculate the other trigonometric ratios, cos A and tan A. So what is the cos A definition? Cos A is adjacent side upon hypotenuse. Adjacent side how much? Adjacent side is root 7 upon hypotenuse how much? 4. Okay, root 7k, 4k. So k we can cancel in the ratio. So root 7 by 4. Now next, what is the next thing we have to find? Tan A. So tan A is equals to opposite side by adjacent side, right? So opposite side, what is the opposite side? 3k, or upon adjacent is root 7 k, root 7 k. So ratio 3 upon root 7, 3 upon root 7. This is how we can calculate the sine. When sine of angle is given in the form of ratio, we can find the other trigonometric ratios like cos A and tan A, like this. Understand? So what is the next thing given? Given 15 cot A equal to 8, find sin A and secant A. See here, let us rearrange this one first of all. Cot A, 15 cot A is 8. So 15, send this 15 to that side. So what happens? Cot A is equals to 8 upon 15. If you send this side, it becomes 8 by 15. So now see here, this is a, let us take this triangle ABC, right angled at B. So this side is becomes opposite to right angle is hypotenuse, and what we have to find? A. So trigonometric ratio of angle A. So where is the angle? A here. So opposite to this angle we have, what is this? Opposite side, and this one is left with adjacent. Understand? So cot A, what is the definition of cot A? Cot A is how much? The definition is what? Cot A is adjacent side by opposite side. So what is given? 8 upon 15. So adjacent side, where is the adjacent side? It is 8. And what is the opposite side? It is 15. But it is a ratio, right? So we have to take 15k, 8k. When it is given in length in centimeters, we will take directly. But when it is given in ratio, we have to take k. Okay. Next, find sin A and secant A. Okay, let us find sin A. If I want to find sin A and secant A, let us first finish this triangle. See here, it is given 8, 15, and we have to find the first hypotenuse. So hypotenuse square is equals to the sum of the squares of the other two sides, right? So what is the AB? 8k square plus 15k square. This is AC, right? So 8k square means 64k square. 15 15s are 225k square. This is 289k square. Understand? AC square. So square root, taking square root on both sides, what will happen? 289k square. So AC becomes 289, root of 289 is 17, and root of k square is k. So this becomes 17k. Understand? Okay. Now let us find sin A, the trigonometric ratio, sin of angle A. Sin of angle A definition is opposite side by hypotenuse. So what is the opposite side? The opposite side is 15k by hypotenuse how much? 17k. So this becomes 15 upon 17. Next, what is the next thing? Secant A. What is the definition of secant A? Hypotenuse upon adjacent side. So hypotenuse how much? 17. And what is the adjacent side? 8. Okay, 17k upon 8k. K cancel. It is 17 upon 8. I hope you understood. Okay, this is the next thing. So next, what is given? Secant theta is given as 13 by 12. Calculate all other trigonometric ratios. Calculate all other trigonometric ratios. Understand? Now, see here, secant theta. What is the definition of secant theta? Hypotenuse by adjacent side is equals to 13 by 12, because secant theta is Definition is this, and this ratio is given. Okay. Now see here secant theta. So we can take theta anywhere, here or here, wherever it is, because this is right angle. We won't take here. This right angle opposite it is hypotenuse. Okay. Next, let me take this as theta. So if I take this theta, so opposite to this angle, this is opposite side, and adjacent to this is adjacent side. So hypotenuse how much? 13, and adjacent is how much? 12. So I have to find first of all this side. So definition from the Pythagoras theorem, hypotenuse square is equals to the sum of the squares of the other two sides, right? So AC is how much? 13k whole square equal to AB how much? We don't know, we have to find, plus BC is how much? 12k. Understand? Let us bring this to the other side. 13k is 169k square. This 12k square, if it comes 12k whole square, if it comes this side, 12 12s are 144k square equal to AB square. Okay, 169 minus 144, it is 25k square. That implies AB square. Okay, taking square root on both sides, root of 25k square. So AB is equals to root of 25 is how much? 5. Root of k square is k. So AB how much? 5k. So this is also a trigonometric triplet, 5, 12, 13. So next, find the all other trigonometric ratios. Let us start from sine theta. Sine theta definition is opposite upon hypotenuse. Opposite side. What is the opposite side? See here, opposite side is 5k upon, what is the hypotenuse? 13k. It is 13k. So 5 upon 13. Next, what is cos theta? Next, see cos theta is equals to adjacent side upon hypotenuse. What is the adjacent side? 12k upon 13k. 12 upon 13. Next, tan theta. So what is the definition of tan theta? It is opposite side upon adjacent side. So what is opposite side? 5 upon adjacent side. Opposite is 5, adjacent is 12. So 5 upon 12. Next, cot theta. So cot theta is equals to adjacent side by opposite side, right? So adjacent side how much? 12k upon 5k. So 12 by 5. We also know that cot theta is the reciprocal of tan. So if you reciprocate, you will get the same thing here. Understand? Also you see, observe these two, secant and cos. They are reciprocals to each other. See, this is 13 by 12, this is 12 by 13. Next, cosecant theta. Cosecant theta is hypotenuse upon what? Opposite. This is the reciprocal of sin theta, right? So how much? Hypotenuse is 13k and the opposite side is 5k. So 13 upon 5. This is how we can find all the other trigonometric ratios when one of the trigonometric ratio is given. So first, what we are going to do, from this we are going to complete the right angle triangle. This 2 ratio is given. The third one we will find from the Pythagoras theorem, and then we will easily write the other trigonometric ratios. Next, see here, if angle A and angle B are acute angles such that cos A equal to cos B, then prove that angle A equal to angle B. Angle A equal to angle B. This is what we have to prove. Now see here, from this is right angle, right? So this becomes hypotenuse and this becomes opposite and this becomes adjacent. And here similarly this is hypotenuse, this is opposite and this is adjacent. Okay. Now what is given here is cos A equal to cos B. If angle A and B are acute angles such that cos A equal to cos B. So what is given? Cos A equal to cos B. It is given, right? Okay. Cos A, definition of cos A. Here see cos A means what? Adjacent upon hypotenuse. Here also cos means adjacent upon cos of some angle, adjacent upon hypotenuse. So cos of angle A is how much? Cos of angle A is opposite mn, sorry, adjacent, right? Cos means adjacent. So adjacent, what is the adjacent? Am upon hypotenuse. What is that? An. That is equals to, in this, what is the adjacent? Bp upon BQ, adjacent upon hypotenuse, right? BP upon BQ. Okay, let us rearrange this. So we can do AM, we will bring BP here, and okay, we will bring this and we will take this AN by BQ. This is unaltered. Okay, this and this we are not changing, only this we are taking to this side and this we are bringing this side. Okay. Now why I have done this way is, see here, AM BP, okay, and AN, this is hypotenuse, and BQ, this is hypotenuse. So this is altitude and this is hypotenuse. I have taken the ratios of the corresponding sides. Okay, let us take this as, suppose this to be K and put this as 1. Okay, now what we will do is, from this let us calculate Mn and PQ ratio, Mn by PQ, right? Let us find what is the value of Mn. Mn is equals to, see here, Mn square from right angle triangle. First of all, let us do this way instead of going this way. See here, this is hypotenuse square, An square is equals to the other two sides, sum of the other two sides squares, okay, plus Mn square. What we have to find? Mn, right? So send this to this side, An square minus Am square equal to Mn square. That implies taking square root on both sides, Mn square root is equals to root of An square minus Am square. Understand? So this cancels, Mn is equals to An. See here, look carefully, see this two, equate this two, An upon BQ is equals to K, right? So if you send BQ that side, An becomes K BQ. The similar way, take this two, Am by BP is equals to K. So send this side, Am equal to K BP. Understand? Now see here, An and Am, we have here An and Am. Now what I will do is, see here, An is how much? K KBP, right? KAN is KBQ whole square minus AM how much? KBP. KBP whole square. Understand? So this becomes K square BQ square minus K square BP square. So K square, if you take common, okay, it will come out, and this becomes K into root of BQ square minus BP square. So Mn becomes what? Mn becomes K into root of BQ square minus BP square. So here again we apply the Pythagoras theorem. BQ square is equals to BP square plus PQ square. So what I want? PQ, right? So send this to this side. BQ square minus BP square is equals to PQ square. That implies PQ square is equals to root of BQ square minus BP square. Understand? So from, see here what will happen, this PQ is equals to root of BQ square minus BP square. Understand? Now Mn by PQ. Mn by PQ. So let us write Mn by PQ, corresponding sides. So Mn is how much? K times root of BQ square minus BP square. Understand? And whereas PQ is how much? Root of BQ square minus BP square. So this and this gets cancelled. Mn by PQ will be K. This becomes K. So from 1 and 2, see this RHS is K, this RHS is also K. So LHS should be same. That implies AM by BP is equals to AN by BQ is equals to Mn by PQ, which means the corresponding sides are what? Proportion. The corresponding sides are proportion. See, AM upon BP is equals to AN upon BQ and Mn upon PQ. These are all proportionate. Understand? Which means from triangles chapter we know that if the three sides are proportionate, the ratio of the three sides are proportional, then these two triangles are similar. These two triangles are similar by what rule? By triplets similarity criterion. These two triangles are similar. So these two triangles are similar. Therefore, by triplets criterion, similarity criterion, triangle AM N similar to triangle BPQ. That implies angle A equal to angle B. Why? Because angle A equal to angle B. What? Why? Because corresponding sides, right? So of similar triangles are equal. Understand? So when two triangles are similar, then their angles are also equal. Understand? So angle A equal to angle B. This is how we can prove. This is the procedure which is followed in the textbook. Okay, there are some certain ways this can also be solved. Okay, there is an alternate method also which we can solve. Understood? But this is the procedure that is given in the textbook. See, for example, in the textbook for this question is given. Okay, here this question is given in the textbook, sin B, sin Q. Okay, the similar way we will solve. Understand? And one more for your practice, I am giving you tan A and tan B. Practice this, because this kind of questions are little bit, see, you need to work out. Once you are good at it, you can easily do this. Okay. Now let us go to the next problem. If cot theta equal to 7 by 8, evaluate 1 plus sin theta into 1 minus sin theta by 1 plus cos theta into 1 minus cos theta. So let us first understand. See, cot theta. What is the definition of cot theta? Cot theta is adjacent side upon opposite side. So what is the adjacent side? 7 upon 8. So theta. So theta is given here. This is 90 degrees, right angle, right? So this is hypotenuse. This theta means this is opposite and this is adjacent. Okay. Now what we need to find is, see here, adjacent is how much? 7. Ratio means we have to take k. Opposite 8k. Understand? We need to find the hypotenuse. How we will find the hypotenuse? AC square is equals to AB square plus BC square. So AB is how much? 7k plus BC is 8k. 7 7s are 49 k square plus 8 8s are 64 k square. So 113 k square. So if you take square root on both sides, so what will happen? AC will be equal to root 113k. This becomes root 113k. Now what is given here is 1 plus sin theta into 1 minus sin theta. So this is of the form, you see, we can do a couple of ways, but here you see it is of the form a plus b into a minus b. A plus b into a minus b is a square minus b square, right? So let us apply that formula so that we can easily simplify this. So 1 plus sin theta into 1 minus sin theta is 1 square minus sin square theta upon 1 plus cos theta into 1 minus cos theta is also again the same formula, 1 square minus cos square theta. So we know that, see here, 1 minus sin square theta is cos square theta, because we know the identity, sin square theta plus cos square theta is equals to 1. So 1 minus sin square theta, if sin square theta goes that side, cos square theta equal to 1 minus sin square theta. Understand? So similar way, if you send cos square theta to the other side, it becomes 1 minus, understand? Now 1 minus sin square theta is cos square theta, by 1 minus cos square theta is sin square theta. So cos by sin is how much? Cot square theta. So cot theta is 7 by 8. So cot square theta is 7 by 8 whole square. So 7 7s are 49, 8 8s are 64. This is the answer. But here in the first exercise we have to do without using this identity. So let us solve this. 1 plus, see, from here without using this identity. Here I am using this identity, right? So I can use this 1 minus sin square theta by 1 minus cos square theta, that is equals to, see how I am going to do. So how I am going to do is 1 minus sin theta. What is the definition of sin theta? Sin theta is equals to opposite by hypotenuse. Opposite is how much? Opposite is 8. Hypotenuse is root 113. That k we can cancel, right? Okay. 8 upon root 113. 8 by root 113 whole square by 1 minus cos square theta. Cos theta. What is the cos theta definition? Cos theta is equals to adjacent upon hypotenuse. Adjacent is how much? 7. 7k upon root 113. Okay, k cancel, 7 upon root. Okay, now see here, 1 by 1 minus 8 8 is 64 upon root of 113 whole square is 113 by 1 by 1 minus 7 7s are 49, because we are squaring numerator and denominator. 8 square is 64, root of 113 whole square is root cancels. Here also 7 7s are 49, root of 113 square is 113. So 113, this becomes 113 minus 1 into 113 into 1, 113 minus 1 into 64, 64 upon 1 into 113 is 113 by 1 into 113, 1 into 49 by 113. This cancel. 113 minus 64 is 49 and 113 minus 49 is 64. So see, the same answer we got, but here without using the identity we have done this. If you use the identity, it becomes very very simple, understand, but here we will do this way. Hope you understood. See here, 7 by 8, same, similarly before, this is adjacent side by opposite is equals to 7 by 8. So this is hypotenuse and this is opposite and this is adjacent, understand. Now, so adjacent is how much? 7k, opposite is 8k and this is root 113k, just the previous slide we have calculated. Okay, now evaluate cot square theta. Cot square theta, see, this is cot theta. So cot square theta is equals to what? Cot theta whole square. So cot theta is 7 by 8 whole square. 7 7s are 49, 8 8s are 64. Okay, just he wanted to show you that this is also equal to cot square theta, understand. See here, 3 cot A, if 3 cot A equal to 4, check whether 1 minus tan square A by 1 plus tan square A equal to cos square A minus sin square A or not. Consider triangle ABC in which angle B is 90. Angle B 90 means what is this? Hypotenuse. Okay, angle A here. So opposite to this is opposite side and this is adjacent side. Okay, now let us take this 3 cot A equal to 4. So cot A equal to 4 by 3. I am sending 3 to the other side. So the definition of cot is adjacent upon opposite. So 4 upon 3. Adjacent, where is the adjacent? This is 4k, this is 3k. I have to find hypotenuse. So hypotenuse square from Pythagoras theorem is equals to AB square plus BC square. So AB is how much? 4k whole square plus 3k whole square. So 4 4s are 16k square plus 3 3s are 9k square. So if you add up 25k square, this is AC square. Taking square root, what will happen? So this AC becomes 25, root 25 is 5, root of k square is k. Understood? So this is 5k. Now let us see, check whether 1 minus tan square A by 1 plus tan square A equal to cos square A minus sin square A or not. So for that we need to find tan value, cos value, sin value. Okay. Now let us first find what is tan A. Okay, tan A is opposite side by adjacent side. So opposite side how much? 3k. Adjacent side is how much? 4k. So that is 3 by 4. Tan A is how much? 3 by 4. Next, sin A. Sin A is opposite side by hypotenuse. So opposite side how much? Opposite side is 3k and hypotenuse is 5k. So this is 3 upon 5. Cos A. What is cos A? Adjacent side upon hypotenuse. So adjacent side how much? 4k upon hypotenuse is 4 by 5. The answer is 4 by 5. Now let us check this. 1 minus tan square A by 1 plus tan square A is equals to cos square A minus sin square A. 1 minus tan A. How much tan A? 3 by 4, right? 3 by 4 whole square 1 plus 3 by 4 whole square is equals to cos A how much? 4 by 5 whole square minus sin A how much? 3 by 5 whole square. See now, this is 1 by 1 minus 3 square 9, 4 4s are 16 upon this I can write it as 1 by 1 plus 3 square 9 upon 16. Why I have done this way? Because to easily make the LCM. Understand? So 4 4s are 16 upon 25 minus 9 upon 25. Okay, 16 ones are 16 minus 1 nines are 9 upon 1 into 16 16. 16 ones are 16 plus 1 into 9 9 upon 1 into 16 16. So 16 16 cancel. So this is equals to, so LCM here 25 is same, right? So 16 minus 9. So 16 minus 9 how much? 16 minus 9 is, this is 7, right? See, 16 minus 9 is 7, 16 plus 9 is 25. Here 16 minus 9 is how much? 7 and 25. So LHS equal to RHS. Okay, yes, it is correct. Whether it is equal or not means yes, these both are equal. These both are equal. Understand? Okay. Next, in triangle ABC, right angled at B, if tan A equal to 1 by root 3, sin A cos C plus cos A sin C, we will find this one. Understand? See here, let us take a triangle ABC, right angled at B, which means this is what? Opposite to the right angle is, this is hypotenuse, and we want A, right? So angle A, opposite to this angle A is opposite side, and adjacent to this is adjacent side. Okay. Now what is given? Tan A is given. What is given? Tan A is given 1 by root 3. Door locks you. Understand? So what is the definition of tan? Opposite upon adjacent. How much? 1 by root 3. So what is opposite? 1, adjacent root 3. Understand? Now we will find the hypotenuse. AC square is equals to AB square plus BC square. AC how much we have to find, right? AB is root 3 whole square plus BC is 1 square. Root 3 whole square is 3 plus 1 is 1. So 4. So AC square is this. So root of AC square is equals to root 4. So AC is equals to root 4 is 2. So this is how much? 2. Now we have to find this one, sin A cos C plus cos A sin C. So sin A, what is the definition of sin A? Sin A cos C plus cos A sin C. Definition of sin is opposite side by hypotenuse. Understand? And here we need to see C value also. So let us redraw this one. A, B, C. This is the angle C. So this is opposite. This is adjacent because this is hypotenuse. So the values remain same, 2, root 3, 1. They remain the same. Now see what is the definition of cos adjacent upon hypotenuse plus cos definition is adjacent upon hypotenuse, sin is opposite upon hypotenuse. So sine of angle A, sine of angle A, sine of angle A is opposite by hypotenuse, 1 by 2, adjacent upon cos of angle C, cos of angle C. So adjacent upon hypotenuse, this is also 1 by 2 plus cos of angle A, cos of angle A, adjacent upon hypotenuse, root 3 by 2. Sine of angle C, sine of angle C, sine means opposite upon hypotenuse, root 3 by 2. 1 into 1 is 1, 2 2s are 4 plus root 3 into root 3, 3 upon 2 2s are 4. So LCM, denominator is same, add up the numerators, 1 plus 3, it becomes 4 by 4, 1. What is the value? This value is 1. So next, similarly, see here. So this is root 3, 1, 2, right? And here root 3, 2, 1, but here this is opposite. When angle A is given, this is opposite, this is adjacent, this is hypotenuse. When angle C is given, this is opposite and this is adjacent and this is hypotenuse. Now cos A definition, what is the cos A definition? Cos means adjacent upon hypotenuse, cos means adjacent upon hypotenuse, minus sine opposite upon hypotenuse, this is opposite upon hypotenuse. Okay. Now see here, adjust cos of angle A, cos of angle A, adjacent upon hypotenuse, root 3 by 2, and cos of angle C, adjacent upon hypotenuse. So 1 upon 2 minus opposite by hypotenuse, sine of angle A, sine of angle A, opposite upon hypotenuse, 1 by 2. Sine of angle C, sine of angle C, opposite upon hypotenuse, root 3 by 2. Root 3 into 1, root 3, 2 2s are 4, minus 1 into root 3 by 2 2s are 4. So they get cancelled, it becomes 0, the value becomes 0. Understand? See here, in triangle PQR, right angled at Q, PR plus QR is equals to 25 and PQ is equals to 5 centimeter. Determine the value of sin P, cos P and tan P. So here the triangle ABC, sorry, PQR is given here. Here PQR, right angled at Q, right angled at Q. So this becomes hypotenuse. Okay. Now P values we want, right? So this is P. So opposite to this is opposite and this is adjacent. Understand? What is given here? PR plus QR, 25. Understand? PR plus QR is equals to 25 and PQ is equals to 5. PQ is equals to 5. Understand? Now what we need to find is, so only one side is given, PQ is given as 5 and PR plus QR is given as this much. So let us take the hypotenuse, right? PR is equals to 25 minus QR, 25 minus QR. Let us take this as 25 minus QR. So this is QR, right? Let us suppose this to be X. So this becomes 25 minus X. So if I want to find this one, see here, hypotenuse square, PR square is equals to PQ square plus QR square, right? So so PR is how much? 25 minus X. Here QR I have taken as X, right? Whole square equal to PQ how much? PQ is 5 square plus QR is how much? X square. So this is A minus B form, right? A square plus B square minus 2 into A into B plus 5 is okay, is equals to 5 square is 25 plus X square. So this is 625 plus X square minus 225 is a 50 X equal to 25 plus X square. So X square cancel. This 50x will go this side, becomes plus 50x. This 25 will come this side, this becomes 625 minus 25. So this becomes how much? 50x is equals to 600. So x is equals to 600 upon 50. So 5 ones are 5, 12s are. So this becomes how much? X equal to 12. This becomes 12. So this becomes 25 minus 12. How much? 13. So 5, 12, 13 is a trigonometric triplet. Now we got the triangle with P, Q, R, this 5, 12 and 13. Now what we have to find? Sin P. So opposite to this is opposite to the 90 degrees, this is hypotenuse and this is adjacent. This is adjacent. So sin P is equals to how much? Opposite side upon hypotenuse. So opposite side how much? 12. Hypotenuse is 13. Cos P how much? The definition is adjacent upon hypotenuse. So adjacent is how much? 5 upon hypotenuse is how much? 13. So tan P, the definition of tan P is what? Opposite side by adjacent side. Opposite side how much? 12. Adjacent side how much? 5. So this is how we can do this problem. I hope you understood. See, the similar problem is there in the textbook of a solved example. Try this one. Okay, don't ignore the solved examples, they are very important. So state whether the following are true or false, justify your answer. The value of tan A is always less than 1. The value of tan A is always less than 1. It is false, right? Why? Because we know that tan theta value is also greater than 1. See here, definition of tan what? Opposite by adjacent. Understand? So tan is opposite by adjacent. So sometimes we know that this side can be equal. Sometimes they both can be equal. Sometimes AB is what? AB is greater than BC. It can be greater, right? AB can be greater than BC or BC can be greater than AB or AB equal to BC, right? Anything can be possible. So this value can be sometimes greater than 1, sometimes less than 1, sometimes equal to 1. So it is not always less than 1. It can be equal to 1 or less than 1 or greater than 1. Next, secant A is equals to 12 by 5 for some value of angle A. Yes, this can be possible. Why? Because see, secant is hypotenuse by adjacent. So hypotenuse, this is 12, right? Hypotenuse is the highest, longest side. This is 12 and adjacent side is smaller. So this is quite possible. So secant can be greater than 1 for some angle of A. Hence the given statement is true. Cos A is the abbreviation used for the cosecant of angle A. Wrong. Cos is for cosine. Cosine of angle A. Cosine of angle A. It's not cosecant of angle A. Understand? This cosecant is abbreviated as cosec. I understand. In some books it is written as like this. But we mostly use this cosecant A. This is cos means cosine, cosine of angle A. Next, cot A is the product of cot and A. Wrong. This is also wrong. So, cot alone has no meaning without its angle. Understand? We have definitions for cot of some angle, not for cot alone. So, this is wrong. Cot into A, no. Cot A. We have to have both. Then only there is definition. So, cot A is not the product of cot and angle A. Cot separated from angle A has no meaning. Hence, the given statement is false. Sin theta equal to 4 by 3 for some angle theta. So, sin means what? Sin means what? Opposite side by hypotenuse. Opposite side is 4, hypotenuse 3. So, hypotenuse is the longest side, right? So, longest side cannot be less than the other side. So, this statement is wrong. So, sin theta can never be greater than 1. Sin theta can never be greater than 1. Understand? So, this is the thing. So, this is exercise 1. Thank you.